Hi guys, and welcome to our last chapter of Algebra 1 class. Since we don't have too much time left in the semester, we will only be covering one section from chapter 10, which is section 10-2, but there are two different topics that we'll be covering. So over the course of this week, we will be learning how to simplify radicals, and then we're also going to be learning how to simplify radicals when they're presented as a fraction. But for today, we're just going to take a single radical with just numbers in it, and we're going to learn how to simplify them. Now, for this chapter, you should not be using your calculator. When we use our calculators, we're not going to get a simplified radical, we're going to get a decimal. And you have to be able to show me work to get your simplified radical. So let's begin. In this chapter, we're going to give you square roots of non-perfect squares. So those are numbers that cannot have a square root, where it's just a whole number, right? These are numbers that if I typed it in my calculator, I would get a decimal answer. And that decimal answer, it's like a super, super, super long decimal, right? Like it doesn't stop when your calculator stops. It actually keeps going on and on and on forever. Those are called an irrational number. Now, our goal today is to take these square roots and make them smaller square roots. So here I'm starting with the square root of 605. I'm going to try to simplify that to become a smaller square root. My first step is to factor tree the 605 down to its prime factors. A factor tree is when you take a number and you split it into a multiplication problem. So 605, that can be rewritten as a multiplication problem 5 times 121. And then you keep splitting the numbers until you only have prime numbers at the end of each line. Now, a prime number is a number that can only be split into one and itself. For instance, right now, 5 is a prime number because if I wanted to split it into a multiplication problem, the only multiplication problem I could do was 1 and 5. So I'm going to leave the 5 alone, but I can split the 121 again. 121 can be rewritten as 11 times 11. Now, 11 is also a prime number, and so at this point in time, I think I'm done with my factor tree. When you're done with your factor tree, you're going to take the number at the end of each branch. Nothing in the middle, just the ends. And you're going to put them back into the square root symbol. Now, I like to reorganize them smallest to largest. Sometimes they don't come out that way in my factor tree, but when I put them back in, I like to put the smallest number first and then gradually work my way to the biggest number. So I'm rewriting 605 as 5 times 11 times 11. Now, we are doing square root problems. A square root is when we look for a number that gets multiplied by itself to become the original number. So what we're looking for in these problems is we're looking for two of a kind. Can we find two numbers that are the same? And then we can square root them. Now in this problem, my two numbers that are the same are the 11s. I have two 11s. Once you find a pair of numbers, one of the numbers gets to escape out of that radical, and the second number in the pair, he just kind of disappears. He goes away. Think about it. When you do the square root of 4, you get the number 2. But 4 was 2 times 2. Where did the other 2 go? Just kind of disappears. So same thing happens here. The 11 goes out of the radical, and the second 11, just cross him off. He's not going to be there anymore. Any number that did not have a partner, that was not part of a pair, that you did not circle, stays underneath the radical sign. So the 5 will stay underneath. And my final answer to this problem is 11 rad 5. Rad is just another way of saying square root. All right, let's try one more together. I'll go a little bit faster on this one. So the square root of 140. Now, what you split it up into doesn't matter. Me personally, I normally split by 2 as many times as possible until I can't split by 2 anymore. But maybe you guys are thinking, oh, well, this is 14 times 10. And again, what you split it into doesn't matter. When you're done, we're all going to end up with the same prime numbers. So I went ahead and did 14 and 10 because I figured that's what you guys would probably do. Me personally, I probably would have done 2 and 70, right? And then 2 and 35, and I kept going like that. But 14 and 10 is fine. Now, neither of these are prime, so I am going to have to split them both. So 14 can split into 2 and 7. Now, those are prime. And 10 can split into 2 and 5. Those are also prime. So I'm going to take the numbers at the end of each branch. I'm going to rearrange them. I'm going to go from smallest to biggest. By rearranging them, that also puts my pairs of numbers right next to each other. It makes them very easy to find. So I had 2 2s, a 5, and a 7. I do have a pair of numbers. I have a pair of 2s. So one will get out and the other just kind of disappears. Now the 5 and the 7 are not a pair of numbers because they're not exactly the same. So both of those will need to stay underneath the radical. And since they're both staying underneath the radical, I am going to re-multiply them together under the radical symbol. So I'll have a 2 on the outside and then I'll 35 on the inside. The same thing is true if you have more than one number that gets out of the radical. So if you have like 2 numbers, like maybe a 2 and a 3 escaped, then you can multiply the 2 and the 3 together and you would have a 6 on the outside. So if you have more than one number that gets out of the radical, those also multiply together. Everything is multiplying. All right, before you do your homework, why don't you check this one? See if you can do this without my help. If you can do this without me, then I think you're ready for your homework. Go ahead and pause the video, and when you're ready, check your answer. All right, let's see how you did. So I got 7 rad 3. That means that when I did my factor tree, I got 3 times 7 times 7. One of the 7s escaped. The other one is gone. And the 3 stayed inside. This concludes today's only video.